Okay, this flip lesson is on 4.5 radioactive elements. So it was first discovered in 1896 by Becquerel, who discovered the effects of radioactive decay when he was studying uranium. And the particles that are involved in radioactive elements are the beta particles, the alpha particles, the gamma particles, and a neutron. The types of particles and energy what can be produced is all of those, the beta, the alpha, and the gamma rays. During alpha decay, a nucleus loses an alpha particle, which consists of 2 protons and 2 neutrons. So this alpha particle here has 2 neutrons and 2 protons. And we know because it has 2 protons, that's helium. And then the remaining nucleus is going to be a new element. So whatever element this was, it breaks off to helium and a new element with 2 less protons. During beta decay, a neutron inside the unstable nucleus changes into a negatively charged beta particle. So neutrons are neutral, it doesn't matter. It's the same element. It's going to have 1 less neutron, but it's going to have 1 more proton. So this is going to end up breaking off into a beta particle. And gamma radiation has no charge and does not cause a change in either the atomic mass or the atomic number. But what happens is it gives off gamma rays, and it's no loss of mass or loss of particles. So if you take a radioactive sample here and you put it in a lead box, the alpha particles will be able to be stopped here by paper. The beta particles are able to be stopped by aluminum foil, like an aluminum sheet, not just foil, but an actual sheet. And the gamma rays will go all the way through, and most gamma rays are actually blocked by concrete. And they use those letters because of the Greek alphabet. So how are they useful? They can help us in chemical reactions and industrial processes and diagnosing and treating disease. So for instance, if we wanted to see how a plant worked, we could put phosphorus 32 in the water and it would be absorbed by the roots and go up to the stem and out the branches, and it would emit these little tracers that we can then detect and see the process by which a plant would absorb water, for instance. That's the end of the lesson.